Alright, continuing with the tips for using a change of variables. We're using change of variables here. It's basically like a substitution. In fact, what's the name of this section? Oh yeah, integration by substitution. So our tips are to choose a u. Let u equal the g of x, the interior function. Some terms raised to a power. Some sort of trig function within a trig function. Things like that. Find du. So take the derivative of your u, but don't write it as u prime. Write it as a differential. Du equals g prime dx. Then solve for dx or whatever it is you need to solve for. We will have some examples here where we're actually going to have to not solve for dx. We're going to have to solve for something different. Substitute this in for dx, or whatever you're substituting it in for. If you need to, you may have to solve u equals g of x for x and substitute that in, so that once you have it all substituted out, there are no x's remaining. Then evaluate the integral as normal. That's step 2. And rewrite the answer in terms of x, and also check your answer. Always check your answer on these to make sure you did it right. Sometimes the checking seems like it's going to be a tremendous pain, but it's worth it. And a lot of times it's actually not that bad. So we have the integral of x times the square root of 2x minus 1 dx. Probably what's the first thing I'm going to do? I'm going to rewrite it. So let's make this the integral of x times 2x minus 1 to the 1/2 dx. Now we want to do what? Okay, so what's u going to be? The interior function right here, 2x minus 1. So let u equal 2x minus 1. Now what? Take the derivative of u, yeah. So the derivative of u is du equals 2 dx. Okay, so that means I need to do what? Yeah, solve for dx. Right now, I have u equals 2x minus 1, so this whole thing right here is u. If I solve for dx, I'll be able to substitute out for that. So I get 1/2 du equals dx. Yes, we do also need to solve for x. So notice, like I said, we have the 2x minus 1, that's u. Now we have dx is 1/2 du, but we still have this x hanging out front. So we need to take care of that x that's hanging out front. The way we do that is by taking this equation where we let u equal 2x minus 1, we solve this equation for x. So now I have u minus 1 equals 2x, which means that u minus 1 over 2 equals x. Now we can rewrite everything. Substitute all that stuff in and see where we're at. We have the integral of x, which is u minus 1 over 2. We have 2x minus 1, but that's my u. And that is being raised to the 1/2. And then dx turns into 1/2 du. So, all of my x's are gone, which means I probably did something right. Now I want to evaluate the integral. In order to do that, you're going to have to get used to looking for constants to pull out. I have this divided by 2 right here, which means that what I have actually is actually 1/2. And I have another 1/2 sitting over here, and these things are all being multiplied together. So that means I can pull out a 1/4. Integral of, parentheses, u minus 1 times u to the 1/2, and then just the du. So now the question is, how do I evaluate something that looks like that? Take the derivative, we're integrating. So how are we going to take that integral? Okay, so you're trying to do pattern recognition, and it's definitely not going to work. What was that? I heard it. Distribute. So we have 1/4 integral. U times u to the 1/2 becomes u to the 3/2 minus u to the 1/2. Can we take that integral? Yeah. So don't forget that you can distribute here. All right, we have the 1/4 still out front times so that's u to the 5/2 there. Right, so it's 2/5 u to the 5/2, then minus. Good, this becomes 3/2. So I divided by 3/2, which means I take the reciprocal. 2/3 u to the 3/2. Plus c. Now what? So if I distribute the 1/4 in, now I have 2/20 u to the 5/2, which is to the 5/2, and then yeah, 2/12, so 1/6 u to the 3/2 plus c. Okay, so we back substitute. U was up here, 2x minus 1. So now we have 1/10 2x minus 1 to the 5/2 minus 1/6 2x minus 1 to the 3/2 plus c. Now what? That's it? There's nothing more to do? Well, we don't have to do anything else? What if this was a multiple choice test and my answer looked nothing like that? Because it wouldn't look anything like that. You don't want to factor out least powers or anything like that? You just want to leave it like this? Okay. There's your answer. Sure. What should we do now?
Check our answer.
After we're done crying, check our answer. Actually, you should be done crying at this point. Your eyes should start to feel like they're drying up a little bit. So how do I take this derivative? General power rule. Yeah. So the 5/2 comes down, and I have 1/10 times 5/2. 1/4. 2x minus 1 to the 3/2. The c goes away when you take the derivative. Now what? Oh yeah. There's a minus sign there. Times the derivative of what's inside here, which is 2. Times the derivative of what's inside here, which is 2. Now what? Okay. And I got this 1/4 here. Okay. What else? This answer right now doesn't look anything like what I started with. No. How do we simplify derivatives? How are we going to rewrite it? Least powers. Factor out the least powers. We factor out a 2 here and a 1/4 here, so it becomes a 1/2 out front.
The lowest one is 1/2.
Least powers is the 1/2. So I factor out 2x minus 1 to the 1/2.
And we're left with 2x minus 1 minus 1.
To the first, minus 1 sitting right here. Minus minus 1. Minus minus 1, so plus 1.
So we equal that and we get
The negative 1 and the positive 1 disappear. I have 2x times 1/2, which is x. This turns into the square root of 2x minus 1, which is what we started with. So when you're checking, you're going to want to factor out least powers. Sometimes. Check your work. There's actually only 3 steps. It doesn't take that long. We need some sort of u on this one. 3x. If I make u equal 3x, then I wind up with sine squared u cosine u. That works? That's good enough? Then what?
the integral of sine squared cosine is sine.
The integral of sine squared is cosine? No. Doesn't work. We need a better u. Like I said, you're going to see sometimes you're going to see things that seem like they should be your u. 3x seems like it should be my u, but considering the fact that I'm dealing with trig functions here, it's possible that maybe not. On top of that, I got this squared sitting here. The first thing I'm going to do is rewrite this and try to understand this problem a little bit better. We have the integral of sine 3x being squared, cosine 3x dx. Does that help? No?
I guess, yeah.
It does?
Yeah.
It should.
Yeah, it does.
What are your tricks for picking a u? Something raised to a power. What is raised to a power here?
Sine 3x.
Sine 3x. That's your u. So let u equal sine 3x. So then I take the derivative, and du equals what? No. 3 cosine 3x dx. Now what are we supposed to do? So normally solve for dx, but notice that sitting right here is cosine 3x dx. And sitting right here is cosine 3x dx. If I solve this equation for cosine 3x dx, then I'll be able to substitute in right there, and this whole thing will disappear. So that's what I'm going to do. Solve for cosine 3x dx, and I get 1/3 du equals cosine 3x dx. And this whole thing is sitting right here. So now this will turn into 1/3 du. This is u. So now I have the integral of this guy, which is u squared, this guy, which is 1/3 du, and this is a simple integral now to take. The 1/3 goes out front, and as you get more practice, you'll just do that automatically. 1/3 integral u squared du turns into 1/3 u to the third over 3. So you're right, 1/3 times 1/3 times u to the third plus c. Now I back substitute, and I have 1/9 times cosine, u is sine, sorry, to the third, which I can rewrite in the context or the terms of the way they wrote that problem. 1/9 sine to the third 3x plus c. For the check, we have 1/9 sine 3x to the third plus c. So what do we get when we take the derivative? So we have now, okay, so the derivative of what's inside, derivative of sine 3x is, okay, and then the 3 and the 1/3 are gone. The squared can be written like so. And that's what we started with. So that's the answer. This is the answer. So for this one, what are we making new? Something inside raised to a power. Seems like a good place to start. If not, if you wind up in a dead end, then go back and try to find some other u. So then du equals 2x dx. Well, I have what? I have x dx sitting right here. So all I need to do is solve for x dx, which means 1/2 du equals x dx. So now this is a u, and this is my 1/2 du right here, which means that I have the integral of, this guy right here is u to the 4th. X dx is 1/2 du. So I'm going to write 1/2 du. Now I can integrate, the 1/2 is still there. U to the 5th, 1/5 u to the 5th plus c, so I get 1/10 times x squared, I keep wanting to write a 2 for some reason, x squared plus 1 to the 5th plus c. Of course we want to check our answer, so we use the general power rule here. The 5 comes down and gives us 1/2 times the thing that's inside, decay the exponent by 1, times the derivative of what's inside, and the c goes away. The 1/2 and the 2 go away, and so I'm just left with x times x squared plus 1 to the 4th, which is what I started with. So I'm good. We have a general power rule for integration as well. It works like the general power rule for differentiation. We've kind of been using it already. U substitutions for quantities raised to a power result in this rule. The integral of some sort of interior function raised to a power times its derivative is simply the function raised to one higher power divided by that one higher power plus c. It kind of takes what we just were doing and pattern recognition and puts them together. So for example, notice on this one, the inside function 3x minus 1, the derivative of that is 3. And the 3 is sitting right there. So I can use the general power rule for integration on this one. It's not like I need to, but I can because I see the pattern. And it's just going to be this inside function, 3x minus 1, to a new power, 5, divided by 5 plus c. That's the answer. For the second one, again, notice that we have some sort of function sitting here, and its derivative is sitting right here. There's a lot of patterns, or a lot of functions that I can give you that kind of have this sort of appearance to them. We're going to do a whole chapter on this sort of thing coming up pretty soon. So this is this derivative. Because of that, and the exponent here is 1, I can use my general power rule for integration and wind up with x squared plus x squared divided by 2. This last one, it might help to rewrite it. Integral 3x squared times x to the 3rd minus 2 to the 1/2 dx. Do we have that pattern? Yeah. The derivative of what's inside is 3x squared, which is sitting right here. Therefore, the pattern is here, which means that this integral is simply x to the 3rd minus 2 to the 3/2 divided by 3/2, or 2/3 x to the third minus 2 to the 3 halves plus c.